talk about, like I said, factorizing quadratic trinomial. That's a fancy way of saying an algebraic expression with 3 terms, and the highest power is the x squared term. Alright, so the variable, it doesn't have to be x squared, the variable has a highest power of 2, squared. That's a quadratic trinomial. So x squared plus x plus 1. That's a quadratic trinomial. The highest power is x squared, and there's 3 terms. Alright, typically it's in this form. There's an x squared term, there's an x term, and then there's a constant term, as we call it, or a numerical term. Okay, then we have 2x squared plus 4x plus 2. That's also a quadratic trinomial. Right, there's infinite numbers that you can go about. X squared plus 4x plus 4, and you can think of any other number of quadratic trinomials. The point is, it's got a, generally speaking, an x squared term, an x term, and a constant term. Alright? So we follow so far. Now, there's a particular way that we can factorize these sort of quadratic trinomials. And so that's what we're going to have a look at, think about what the factors are, so that we can then factorize this expression. So that's what it's all about. If we can factorize something, then we can simplify expressions, and then we're able to manipulate things better to make it easier for us to handle. Now, I would like you to just look at this for a moment. I'm just going to tell you how to factorize this one to start. Now, x squared plus 9x plus 20, when you factorize it, is x plus 4, x plus 5, both in brackets. And we're going to expand that in a sec to show that that's actually true. But this means that x plus 4 and x plus 5, these are both factors of x squared plus 9x plus 20. They're in fact the only 2 factors of this. This is the only way you can factorize it using this method. Okay, remember we've been talking about binomial factors, as the factors that have 2 terms. Okay, we're familiar with this, like the difference of 2 squares and all that sort of thing. So these are the factors of this expression here, of x squared plus 9x plus 20. Okay, now to prove that this is true, we are going to reverse the process and expand the brackets. So let's expand these brackets, x plus 4, x plus 5. Alright, so let's expand it. What's the first term going to be? Rob? Yeah, good. So x times x, correct. X squared. Alright, what's the next term going to be? Good, plus 5x. Alright, what's the next term going to be, Eleanor? Yeah, 4x. And then the last term is going to be 20. Good. Now let's simplify this expression. Simplify this expression, please, Rebecca. Good. So x squared plus 9x plus 20. So are you all convinced that this has factorized this? Okay, we've shown that, we've proven that that's true. Okay, so now the question is, how do we get from here to here? Now, the thing about this is we need to link this 9 and this 20 with the 4 and the 5. And there's a particular link. How do I make 9 from 4 and 5? Yeah, you add them together. If you add 4 and 5 together, you get to 9. Okay? What about 20? What do I do to 4 and 5 to get to 20? Emma? Times. So what I have here is this funny relationship saying I've got these 2 factors involving a 4 and a 5, and then in my original expression I have a 9, which is 4 plus 5, and I have a 20, which is 4 times 5. And that's not a coincidence. That is in fact the rule we use to factorize this expression. And so if you just go up a little bit, so the middle term is 9x, which we get from 4x and 5x, when we expand it, added together. 4 plus 5 is equal to 9. The last term is 20, again we see up here it's 20, which we get from multiplying 4 and 5. 4 times 5 is equal to 20. So we factorize the expression, and this is the important point. We factorize the expression by finding two numbers, which in this case are 4 and 5, that add to 9 and multiply to 20. And so if I find those two numbers, there's only two numbers that do that add to 9 and multiply to 20. And those two numbers are positive 4 and positive 5. If I find those two numbers, I can write it as x plus 4, x plus 5. And that's the way that I factorize this expression. Okay, yes? Yeah, I mean, this is why it's 9x, because you've got 5 times x and 4 times x in your expansion. But in terms of what we're looking for, the numbers, we're just interested in the 9 to start with. We need a number that will add to 9 and multiply to 20. Yes, please. Yeah, it adds to the one with the x, it adds to the coefficient of x, and multiplies to the constant, which is defined in non-constant. Yeah? Adds to this, multiplies to this. Okay, are there any questions so far? I'm going to have a look at another one using a similar method as this. Let me just go up a little bit. Okay, so two numbers that we need to find and multiply to something and add to something. Alright, and if you find those, you can just factorize it straight away. X plus 4, x plus 1. Alright? Let's have a little bit of an example. So I'll give you a moment just to write that down. And then we're going to repeat the process with this one. X squared minus 5x plus 6. Alright? We're going to repeat the process. Let me just pause this. Now, so this one we have x squared minus 5x plus 6. Alright, we've got this expression here, x squared minus 5x plus 6. And I can tell you that factorized, if I factorize this expression, it goes to x minus 2, x minus 3. Right? I'm just telling you that to start with, so we can sort of develop this understanding here. So now I'm going to expand this expression. Right, x minus 2, x minus 3. So let's expand this expression. Daniel, what's the first term going to be? Good, x squared. What's the next term, Olivia? Yeah, good. Minus 3x. Alright, what's the next term, Sean? Another term here. We've got minus 3x. What's the next one going to be? Well, let's do the next one. Minus 2 times x. Minus 2 times x. Good. Minus 2x. And then the last term here, Andy. Well, minus 2 times minus 3. Negative. What's 2 times 3? 6. And a negative times a negative will make it a positive. So it's going to be positive 6. Good. Alright, let me move it up so you can see. Now, so we've got this. So we need to simplify this expression. Let's simplify it. Bring in. Minus 5x plus 6. Now what we need to see is, well, what's the link between minus 5, because I take this whole number here, minus 5 and positive 6 with the 2 and the 3. Minus 2 and the negative 2. Negative 2, negative 2. There's a link between this minus 5, 6, negative 2, negative 3. The middle term is minus 5x, which we get from adding minus 2x and minus 3x. Add minus 2x and minus 3x together, you get minus 5x. Minus 2x plus minus 3x minus 3x equals, plus a negative is minus 5x. Alright? And the last term is 6, which we get from multiplying minus 2 and minus 3. Minus 2 times minus 3 is positive 6. And so, we factorize this expression by finding two numbers that add to minus 5, right? And we've got to remember to think about how we use negatives, that add to minus 5 and multiply to minus 6. And the trick here is that I know it's going to be two negative numbers because this number is positive. The only way I'm going to get a negative number and a positive when I multiply it is by multiplying two negatives. But the same thing applies. We're finding two numbers that add to this term here, that add to minus 5 and multiply to 6. Okay? Are there any questions? We're going to do some examples where we actually try to find these two numbers. Okay? This is just to illustrate to you the point that when you do expand this, we've got our two factors of this expression, we get back to the original. And this is the way we factor it. So if you want to write this down, to factorize a quadratic trinomial of the form x squared plus bx plus c, find two numbers that add to b, okay? The sum of the two numbers in b and that have a product of c. When you multiply the two numbers, they go to the last term. When you add the two numbers together, they go to the middle term. Yes? Yeah. Sorry. Is that alright? Alright, so writing down the last bit and then we're going to look at these examples. First one we've got x squared plus 4x plus 4. So we need a number, find two numbers that multiply to 4 and then add to 4. Okay, I have a product of 4 and have a sum of 4. And yeah, 2 and 2. Okay? 2 and 2, 2 plus 2 is 4. 2 times 2 equals 4. 2 times 2 equals 4 as well. So here we found our number. So what we can do is we factorize this just like that. We go x plus 2, x plus 2. So what do we know about this? What kind of expression is this? It's called a perfect square. Yeah. So you can just write it as x plus 2 whole square. Right. That's just accident. I'm going to leave that to the first one. But just so happens it is. Okay? So you find these two numbers. You're looking at, it has to multiply to this, the product has to be this one, the sum has to be this one. Alright? Now if I go up, we've got x squared plus 3x plus 2. So we need to find two numbers okay, the sum must be this one, which is 3. Then the product, which is then multiplied together, has to be 2. Because that's the one that has to multiply it. That's the one that the two numbers have to have a product. So what two numbers add to become 3 and multiply to become 2? 2 and 1. Yeah, so we got 2 plus 1 is equal to 3. 2 times 1 is equal to 2. So we've got 1 and we have 2. So the way that we factorize this is we say x plus 1, x plus 2. Okay? So we're saying we've found the two numbers that add to 3 and multiply to 2. And so that's the way that we factorize it. And you can always check whether you've done it correctly by re-expanding out of it. You can expand it out again and see whether it's the way that you factorize. You factorize correctly. Right? Next one we have here, x squared minus 5x minus 6. So you need to find two numbers. What does the product of these two numbers have to be? Yeah. So two numbers. Okay. Product is 6. And the sum is what? Sorry, it's minus 6. And the sum is minus 5. And look at this whole term, it's minus 5. So what are two numbers that add to minus 5, that have a sum of minus 5, but multiply to negative 6? Okay, this is where you have to start. Now the first thing to think about is in negative 6, the product is negative 6. So what are the signs of the two numbers there? Yeah, one positive and one negative. Because it's a negative number, the two have to be opposite signs. Okay? So we know that. Andy? Now if you add, what happens when you add positive 2 and negative 3? Minus 3 plus 2 is negative 1. So that's a good guess, but it's not this way. No? Okay? Because the same way, other way around is going to be the same result. So we can't use that, so we can say, well, guess and check is quite a good. It's a 2 and minus 3. So no, that can't be right. And 3 and minus 2 won't work either. That's going to be positive 1. Yes, 1. Yeah, it's negative 6 and positive 1. So if we do negative 6 times 1, that equals to negative 6. Negative 6 plus 1 is equal to negative 5. Right, so it does take some getting, like I said, it takes some getting used to, takes some checking, guessing maybe, or seeing patterns as you come along. So if I factorize this, what I end up with is x minus 6 is our first one, and x plus 1 is our second. Those are my factors that I've used to factorize. Any questions? Here has mud, water. That's the expression. Clear as mud. I've never heard that expression. Has anyone ever heard the expression clear as mud? Yeah. Welcome to the world of expressions, guys. Alright? So the more you do of these, the more you get used to it. I'm going to do a couple more. X squared minus 7x plus 10. So you're looking for product of 10 and a sum of minus 7. Product of 10 and a sum of minus 7. I have to add to this one. I have to multiply to this one. Yeah, so think about it. It's a positive product. It's a positive product. What must the two signs be? It is. Negative 5 and negative 2. Alright, and the reason for that is minus 5 times minus 2 is equal to 10. Negative times negative is a positive. Minus 5 plus minus 2 is equal to, when you add a negative, it's the same as subtracting. Minus 5, you move down 2 spots from minus 5, you get to minus 7. And so what we end up with is x minus 5, x minus 2. That's the way that we factorize this expression. X minus 5, x minus 2. So I'm going to skip this one. Then the one last one. There is a possibility that you may have an expression like this, where the first thing is to look at if there's any common factors within the three terms. And then you factorize it first, and then you do that quadratic trinomial factorization. So do factorization that you're used to by taking out a common factor from each term, and then you factorize it another way. So what's the common factor, the highest common factor in this case? Yeah. 3 is the factor. I would take something else. What x? X doesn't come out of all of them. I'm thinking of a sign. Yeah, I'm going to take out negative 3. I'll show you in a sec. So take out negative 3. This becomes minus 6x. Minus 15 divided by minus 3 is 5 plus x squared. Alright? So if I'm going to rearrange this in the brackets, it's minus 3 x squared minus 6x plus 5. Let's put it up. X squared minus 6x plus 5. So I can ignore the 3 for a moment and think about what are the two numbers that multiply to 5 and add to minus 6? Multiply to 5, add to minus 6. Okay? So, product is 5, sum is minus 6. Here's a trick. If the sum is negative and the product is positive, the two numbers are always going to be negative. Okay? The product is positive and sum is negative, then the two numbers will be both negative. Okay, that's a little trick that you need to remember. Okay, so they're both going to be negatives. If you know what I think it is? Yeah, it's minus 5 minus 1. So minus 5 times minus 1 is equal to 5. Minus 5 plus minus 1 is equal to minus 6. Alright, so what we end up with is equals to minus 3 brackets x minus 1 minus 1 x minus 1. That's how we end up. So sometimes you may have to factorize the whole thing first and then factorize the trinomial within the brackets. So when I'll stop this.